Good afternoon, everyone. Thank you for joining us today, and welcome to my technical seminar on agent architecture for adaptive behavior in autonomous driving under the guidance of Professor Kavya Priya Yamal and co-evaluators Professor Nanda Kumar RB and Professor Sindhu AS. And these are the contents that I'm going to walk you through in this presentation, starting with the introduction, then literature survey, methodology, demonstrations, conclusion, and references. In this seminar, we are going to see the architecture of agent for autonomous driving, that is the organization of agent sensory motor system with the goal to show the adaptive behaviors in its wake state, that is when it's operating or working. The adaptive behavior focused here are topographic organization of motor space, a robust action selection, steering of agent behavior with biasing of action selection, which I'm going to exemplify later in this presentation. When these principles are used to organize an artificial system, the results were similar to those shown by animals like safe, natural, adaptive, and robust behaviors. And also other benefits like ability to deal with a hierarchy of intentions, prioritizing the safety versus legality, and explainable AI. This is the first work in which the autonomous cars are based on a large scale of architecture of the human brain, which involves the ideas from affordance competition hypothesis. To understand better, we should know about path planning and control and adaptive behavior. Path planning and control, all trajectories. Trajectory is nothing but a path followed by projectile flying or projectile motion. For example, path taken by an object when it's thrown or dropped. So all trajectory planning approaches work by first producing a number of candidate trajectories and then selecting the best one. To link this with the biological agenda, it involves two steps. The number one step is action priming, that is nothing but establishing candidate trajectories. And the second step is nothing but action selection, fixing one trajectory for execution. Next is adaptive behavior. So adaptive behavior plays a vital role in improving the robustness of autonomy of robot behavior. The fundamental idea is the notion of affordance, which is a link between perception and action. In affordance theory, perception is not just about a set of abstract features describing the environment, but to identify the ways in which the animal or agent may interact with its environment. Affordance and actions can be seen in affordance competition hypothesis, which suggests that action specification, which is also known as action priming, and action selection are performed by the same neural circuits described among a large set of brain. So potential actions are encoded as patterns of neural activity with salience, that is which reflects the action strength. So now let us consider a challenging situation. The figure 1 here on the screen is an example of dangerous motor-based situation in which objects might fall from the minivan. So this kind of situation can be overcome by a human driver, but an artificial driver need to have the escape strategies, continuous quick adaptation strategies, and more importance on safety rather than legality. So next up is literature survey. So first paper, agent architecture for adaptive behavior is in autonomous driving, published in the year 2020, is one we are morely focused on. And this paper describes how the sensory motor architecture influenced by human brain can be used in bettering the autonomous driving. And the second paper named an adaptive system for autonomous driving, published in the year 2020, involves some approaches and analysis of some algorithms which improves the autonomous driving. And third paper, the MSPRT action selection model for bio-inspired autonomous driving and intention prediction, published in the year 2019, illustrate everything about the MSPRT algorithm as a decision-making tool in the field of autonomous driving. And the fourth paper, titled A probabilistic distribution recursive mechanism for decision making in the brain, published in the year 2018, shows that the dynamics of mapped computations match to relate to the neural activity in sensory cortex and brain. So next is a fifth paper, titled Dreamlike Simulation Abilities for Autonomous Automated Cars, published in the year 2017, has all the other several ways to implement the architectural principles of additional details for the dreams for car implementation. And the final one is named Cortical Mechanisms of Action Selection, the affordance competition hypothesis, published in the year 2007, is one from which the human brain simulation part is excerpted. So, coming to the methodology, let us see the agent architecture shown in the figure 2, which highlights a series of functionalities and their interrelationships. So this represents a large-scale neural network. The figure contains an action priming stream depicted in the solid red arrow, and action selection loop shown in solid green color. In human brain, the action priming stream occurs in the dorsal region of cortex. Here in the figure, the sensory cortex is represented with A and the motor cortex with C. So the dashed arrow is used to show that the human sensory motor is not unidirectional. So in human brain, the information is compressed and expanded by convergence and divergence in the neural pathways. Action priming pathway is used to compute the salience values of candidate trajectories. So the salience here is obtained via learned perception action associations without evaluating the trajectories as an intermediate step. So in the action selection case, the human brain, there is an actions, in the human brain, we can see an action selection loop, at the heart of which is a subcortical brain system of interconnected nuclei called the basal ganglia. The basal ganglia are evolutionary old and common to all the vertebrates, which reflects the fundamental nature of behavioral problems of action selection. So time-efficient decision-making equivalent to the biological solution can be implemented with the MSPRT algorithm, which I'm going to explain next. The basal ganglia are also a locus of learning, which offer a mechanism for influencing decision-making and directing the agent behavior for long-term rewards. Coming to action priming, as safety is the first concern, the vehicle must stay in the road and if necessary, drive over the lane markings or over other extra lane rules. So, but legal intentions are assigned higher salience. That is nothing but importance. So in this way, the agent tries to follow legality over safety, and only if no such legal action solutions exist, it chooses a non-legal physical feasible action that is remaining in the road as the last option. So next, action selection. In the motor cortex region, the action values are stored in such a way that they are readily available for action selection. The most obvious selection criterion is WTA, which stands for winner takes all, that is choosing the action with maximum instantaneous value. But the robust action selection method is to use MSPRT algorithm, which is the abbreviation for multi-hypothesis sequential probability ratio test, as it allows optimal decision making with noisy and uncertain signals. It is because an instantaneous snapshot of salience maps in the motor cortex may not reflect in the distribution of mean values derived by accumulating the evidence over small periods of time, which may offer the basis for the better decision. So this problem of decision making using noisy evidence is a general problem in many domains, and MSVRT is the best solution in such scenarios by giving shortest time to decision with acceptable error rate. The algorithm here depicts the adopted version of MSPRT, a solution for autonomous driving with adaptive behavior. Now, let me exemplify some case scenarios with a few open access demonstrations. Number one is emergent adaptive behaviors. The figure here illustrates emergent behavior. The pictures that we are seeing are camera views. And next to the camera view, there are motor cortex activations shown for different moments of the simulation. So the red part in it indicates total inhibition, yellow part indicates partial inhibition, and the green colored area indicates the affordable actions. And the blue small circle there indicates agent choices. And in the picture, black car is the agent car. So the picture indicates an overview complex behavior that corresponds to what might be commonly expected. So next is robust action selection, WTA versus MSPRT. In the picture on the left is the scenario where two actions becomes equally salient, equally important. So nothing but a case in which the which is ideal to evaluate the effect of noise in an action selection. Here, the green car is the agent car, which is returning to the right lane after an overtake. At point 2, actions A and B have the same salience. With a noise, the WTA criterion causes oscillations which are not produced in the MSPRT as shown in the figure, which is on the right side. So next is proactive action biasing. For this, they have experimented with a total number of 100 simulations, 50 with lane selection biasing and 50 without lane selection biasing. The total, the table here shows the result of the same. So the percentage of the time spent in the car following condition. For biasing, it's 50.5%. For non-biasing, it's 74.5%. And the second column is the mean time spent in one lane between lane changes. So for bias, it's 70.9 seconds, and for no bias, it's 31.9 seconds. The average traveling velocity on the third column there. So for bias, it's 109.5 kilometer per hour, and for no bias, it's 96.7 kilometer per hour. Thus, biasing yields, so the result will be like biasing is a reduction of 32% of the car following time, which is obtained with more frequent lane changes and higher average speed. In the figure 6 and 7, the blue part indicates the left lane, the green part indicates the middle lane, and the red part indicates the right lane of lane selection with proactive bias and without proactive bias respectively. In case of a lane selection with bias, the profiles in the lane are interpreted where the vehicles changes the lane. In case of a lane selection without bias, the velocity profiles reveal that the agent may remain frequently trapped behind the slower vehicles in both the middle and right lane cases. So next case scenario is hierarchical action selection. The scenario here is here in the figure 8 is the road cone falls from a leading car and follows a partial random trajectory. The agent car here which is in yellow color, attempts to either brake or force to change the lane. So the same scenario is shown with the camera views and motor cortex activation in the figure 9. So the figure 10 and 11 shows the probability for collision, stop, and clear. Clear is nothing but overtaking maneuvers for low density and high density traffic respectively. So in low density traffic, the most probable outcome is collision. Otherwise, if the time headway is short, the agent tries to force a lane change. In case of high density traffic, the possibility of lane change is less likely. Coming to the conclusion, to sum up, we went through the sensory motor architecture based few biological inspired principles, which is capable of producing adaptive autonomy while incorporating logical criteria. The advantage of using this agent's architecture is that it yields better decision as it is based on adaptive behavior. To have a better understanding of the project, you can go through this YouTube link. So, and these are the references that I've gone through to understand the concept better. Thank you. Thank you for your attention.
Kavya ma'am. Kavya ma'am.
Sir.
ನಾನು ಕೊಡಿ ಫಸ್ಟ್ ಚಾನ್ಸ್ ಕ್ವೆಶ್ಚನ್ ಕೇಳಕ್ಕೆ.
ಓಕೆ ಸರ್.
ಕ್ವೆಶ್ಚನ್ ಕೇಳಕ್ಕೆ ನನಗೆ ಫಸ್ಟ್ ಚಾನ್ಸ್. ಓಕೆ.
ನೀವೇ ಕ್ವೆಶ್ಚನ್ ಮಾಡಿ ಸರ್.
Who is present? Because it's my domain, sir. I worked on agent system for that
Okay, sir.
purpose.
Okay, sir.
Shreya is presenting, right?
Yes, sir.
Go to your title slide. See, the question which I'm asking, it's to know the concept in depth with respect to the topic which the presentation has been given. Okay, and I already told that it is my domain. My domain in the sense that so people are thinking that I am working on Java, I'm working on .C#.net. It is with respect to the company people. So as a researchers and other things, I'm working on image processing. Like that, some people will tell. I works on agent systems. Okay, I want to ask you a question with respect to this agent. What do you mean by agent?
So here, agent is nothing but the car that they are building, like autonomous car here.
Uh, Not with respect to this topic. Okay, so generally, how do you represent an agent?
Agent is nothing but an artificial system.
Is it something like an artificial intelligence?
Yes.
Huh?
Yes, sir.
Okay. Okay. If you say yes, actually, I agree for this. So many people are aware that, and the boom we have is artificial intelligence and other things. So the artificial intelligence is built up with the agent architecture. Okay. Can you go for the introduction slide? Okay. What are the procedures we told to you people for presenting the same you have followed? So you have to take some scenario while explaining the topic in the same way you have explained it. What is adaptive behavior?
Adaptive behavior is nothing but the decision that the agent takes. Like here, the basic or the foundation for adaptive behavior is nothing but affordance. Affordance is nothing but the proper action need to be taken or the decision need to be taken. So
Can I tell it is a dynamic properties?
yes, sir. It is dynamic in nature.
Dynamic, where actually the agent system will be used to build the artificial intelligence when the system is in a dynamic nature. Okay, that means it does not have a fixed characteristics. Here, the example we can take a traffic system where we can't tell that the traffic systems will be in the same constant in all period of time. It may change, depends upon the situation as well as the scenario. So for that purpose, we have to develop a system which is having in the form of dynamic states. For that, we need to develop a adaptive behavior.
Yes,
So
sir.
go to the methodology. See here, okay, whatever the methodology you have shown. Hello.
Yes, sir.
Okay. So can you tell me what is A, B, and C here?
A is, as mentioned there, sensory cortex. So A is sensory cortex, B is dorsal stream, and C is nothing but motor cortex.
Okay, so as per my opinion, sensor, the agent is nothing but it's a sensory element where it contains it will take the present input as well as it will perform some action, and immediately it will plan some action, and immediately it will perform some action to it. Action is nothing but a motor. Smart sensor is nothing but grabbing the environment, and action priming is nothing but a planning. That means it is something like a thread. Okay, so how this architecture is being adapted in your application? You have explained some algorithm, right?
Yes, sir.
What is that?
MSPRT algorithm stands for multi-hypothesis sequential probability ratio test.
How this probability ratios is been adapted for your application?
Sir, actually, I don't know the exact working of it.
Okay. Okay. We are using some natural inspired algorithms like this, where she has
Yes.
took the diagrams, okay, and is been implemented. The algorithm is been, the agent is been implemented by this procedure. Okay, the procedure which is being listed out like that. So many procedures are available. The and these procedures has been adapted to the practical applications as she has explained. Can you go to the conclusion slide and I'll wind up the my question. Okay, what do you mean by agents decision making?
Like, for example, the path the agent need to be taken.
Okay, so agent is nothing but a piece of software which is being built in between the physical system to interact between the two physical systems. But this agent is not being a static, it will be a dynamic. For that instant, the program will be developed and it will perform its action and it will go off. Okay, so the main purpose of agent system building is to do the decision making, okay, instant decision making. So if you may all observe that the programming language which we are developing is for performing a decision making. Okay, performing a decision making, which one is correct and which one is false. Those things only we are executing. So I'll take committed the things. So ma'am, by this I complete my question. Let other people can take the question and go for the next presentation.
Okay, sir.
Okay, Pa, can I ask a question?
Yes, sir.
Go to the literature survey, Pa. Literature survey part. Now, your third paper, bio-inspired autonomous driving. What is this bio-inspired autonomous driving? What do you mean by this one?
Sir, like here, for example, now as we discussed, like in human brain inspired model.
I think everything is human brain inspired. No? By why? But why didn't you? Why you are using this bio-inspired in this third paper, but not in the other one? In the second one, you say it is a adaptive system. In the first one, you say agent architecture. In the last paper, you are saying probabilistic and distributed recursive method, etc., etc. But what is the difference between all this? Somewhere this word is fascinating me. What actually it is?
So like the other papers are like related to the technology, but here it is interlinked with biological aspects.
Biological aspects, huh? But when you look into the outcome that you have written or the description here, it doesn't say that. No, the description says sequential probability ratio test as a decision making tool. Sequential probability ratio test, something you have mentioned. Now, is it somewhere concerned with the bio this thing, or
So
what is it?
It is concerned, so but I've mentioned like they they've mentioned that it is the best algorithm for using adaptive behaviors.
Okay, let me put the question like this. Please give me the summary of this third paper, the abstract summary of whatever you have understood from this third paper.
Oh, So there they have taken the examples of, like, there also they have taken the human brain architecture, and they have mentioned how it will work, and how the MSPRT algorithm is useful in it, and all those.
Okay, pa. If possible, please share this paper to my mail ID.
Yes, sir.
Just let me look into it. Huh? It is simply out of curiosity, right? Okay, pa. That ends my question.
ಸಿಂಧು ಮ್ಯಾಮ್ ಇದಾರಾ?
ಹಾ ಮ್ಯಾಮ್, ನನ್ ಕಡೆಯಿಂದ ಏನಿಲ್ಲ ಕ್ವಶನ್ಸ್.
ಓಕೆ ಮ್ಯಾಮ್. ಸೊ ವಿಲ್ ಮೂವ್ ಟು ನೆಕ್ಸ್ಟ್ ಪ್ರೆಸೆಂಟೇಷನ್ ಹಾಗಾದ್ರೆ.
ಹಾ ಮ್ಯಾಮ್.
Thank you.